Hi, welcome to another video of my simple programming. And in this video, I like to talk about variables made simple. Why we need these variables and how to use them. Type of variables, operation that we can do or process on these variables. So I will be coming back to the slide as we go. So we can imagine variables as these boxes. A variable is just a container, and with that container basically is easy to work with. But if you have multiple containers in your garage or something, you're going to have a label for them so you can figure out what's inside each container, each one of these boxes. So variables are basically containers, and these containers need labels to identify them. Next, we want to take these variables or containers and store them somewhere. So I wanted to use that shelf as a representation of our memory, and how is this shelf is used to store these variables, just boxes, just like a memory can store the variables. Now, what can we put inside these boxes? Boxes, you can put them on the shelf, but for a reason, because you want to store something. And this something can be oranges, apples, bananas, or it could be any other house items or any item that you want to store. For this example, I'm using apples, bananas, and oranges. Now, if I take one orange and put it right inside that box, and one apple and put it inside this box, and one banana and put it in here, what happens if I open that box? Obviously, I'm going to have a banana. What happens if I open this box? I'm going to have an orange. How many? I'm going to find one inside there, and I'm going to find one banana, and I'm going to find one apple. Okay, good so far. So these boxes, just like a variable, can be cleared. You can empty them. You can empty the box. You can reload it. You can add to it. And it means if I come here and I do clear, these oranges can go back outside somewhere. We're not going to worry about this now. But the boxes have 0 oranges, 0 apples, 0 bananas. What if I go and do that? I'll take this many and put them here. I'll take apples and I'll take bananas. Now if I open the box, now it's completely different. It still have oranges, apples, and bananas, but with a different quantity. Good. Again, I can clear it. I can open and find out what number inside each box, just like a variable. What happens now is I also need to store these variables. I can just have them floating in the air. So I'll take these boxes and store them on the shelf. I'll put one in shelf number 0, if you want to call that a shelf 0. I'll put the apples on shelf 2. I'll put the bananas on shelf 3. I can put them in any order. I can put them in any location. And when I come back next day, they better be there. Orange is going to be 0. Apple is going to be 2. Banana are going to be 3. So if I tell someone go get apples from shelf number 1, obviously that's misstatement here. misleading the person. That's not going to find anything there, right? If I tell someone to go and get bananas from shelf number 3 or just bananas, they obviously going to look and find bananas on shelf number 3. Some other ways you can say, hey, go get whatever on shelf number 0. They're going to find the oranges. They're going to get the oranges. You can maybe tell them how many you want to get from there. And instead of just getting the whole thing, right? You can just tell them, go to shelf number 2 and tell me how many in there. So you only read in the contents of that shelf storage, which has a box or a variable of apples. You didn't do anything. You didn't affect it. You didn't affect the quantity. You didn't move them or anything. Okay, so what are variables? Now we know what variables are. Variables are containers. They can be used to store values that we work with and programming, basically. If you are trying to store some number somewhere and come back and revisit it and see what is that number in a later process, you can go and look for that variable and you'll find out what number is stored. Variables, they have to have a name, they have to have a label, and this label have to be unique. Unique, it means when you say that label or you look for that label, you're not going to find more than one variable with that label. Okay? Variables are stored somewhere in the memory. And we can visualize the memory just like I showed that shelf. And that shelf is really, you can imagine that it's a good representation of a memory. Of course, memory will be a lot longer with a lot of more spaces and location to store. Memory start from 0 address. Maybe we're not going to need to know these addresses. Maybe some languages actually do use these addresses. But in general, variables get stored in memory, and this memory has a location. This location is basically can be identified with an address or can be identified with the label. The label could have its own address in the background where some programming language don't really deal with that part, but they have an address in the memory. Why do we need variables? Well, we need variables because we need to store some values. We need to process some operations on these variables. So if I have 4 bananas and I got more 4 bananas and I want to store them, I can add them, and I'm going to be sure to have the total stored in this variable. Or I can store these bananas, and later if I forget and someone asks me how many bananas do you have, I can go back and read or open the box and figure out that I have 4 bananas if I've stored 4 bananas a while ago. Same thing. So why do we need the variables? We need to store some values in them and process some operations on them. Okay, how to use the variables? Let's go from here to and take another look on a different screen now. Okay, now I jump to a whole different program, and this is NetBeans that I like to use for programming in Java. Now, what I'm going through for your information is not specific to a one programming language. We're only talking about variables, and variables are used in every single programming language. You cannot have a program or an application without knowing and using variables. So this file here that I'm showing is basically a Java class. And in this class, I have a main function or method. And this method has some code in it. Now, I'm not going to go through the construction of a Java class and how all this works. I will have it on a separate video. Right now, we know, or we should know, about main and about a class that is the basic structure in a Java program. Main is where the process starts, and the executable will look for main and start executing all these instructions here to basically produce a program or an application. So for us, we're interested in variables. Variables, like I said, have labels. So I have value 1, value 2, and value 3, and we're going to talk about these labels in a minute. But that's how I create a variable. There is a type. And instead of bananas and oranges and apples, I used an integer. And we're going to talk about more of variable types in a minute. But right now, to create a variable, you have to declare what type of that variable, then label for that variable. And you can, or you can do it later, assign a value inside that variable. Remember, number 1, you have to define the type. Number 2, you have to have a unique label for each variable. Number 3, somewhere in your code, somewhere in your program, you can assign a value to that variable. And you have to do that before you start using it. So skip this for now and look here, and you will find that I'm using a system call to print line into the console, and we'll see how that works. But I'm passing to print line some text, some string, and then a variable, which is the value 1, and I'm adding to it the value 2 and value 3, and I'm trying to insert between these all the values that I stored in these 3 variables. So right now I'm using them. I'm reading that variable, I'm reading that variable, I'm reading this variable. However, I would not be able to do that if I did not initialize these variable with a value in it. If I go here and basically can right click and run file, when you run that file, which is that class here in NetBeans, it will compile it and execute it, and your output will be shown right here. Right now you see some process, and then blah, you will find out that some outputs, and this output will include this line here that you can see it kind of what you would expect when you print it here. That might be a little far for us, but I would suggest that you go and watch the first video on the structure of Java class, how to create the first time Java class and how to use print line, what's the main, and how all that. But here you can see that I was able to print value 1 by adding this here to the input of print line, and value 1 for us, we know it's a 1. So what if I change this? What if I make it 100 and make this 22? I'll make that 39. I'll save it and rerun it again. What do you expect before I do anything? You would expect value 1. And right next to it, you will see the 100. And you will expect value 2 equal, and value 2 here will be 22. And the same for value 3. Let's run that quick and see what happens. What's the output? You see some compilation here, and then you finally see the output of that program, and it program output line says value 1 equals 100, that's what we expect. Value 2 equals 22, that's what we expect. Value 3 is 39. Nice. Okay, so now I go back to my slide and say, okay, how to use variables? Well, first thing is we had to define what type the variable is going to be. Second, we create a unique label for that variable. Third, somewhere in the program, before you actually use that variable, have to initialize that variable by assigning a value and storing something inside that variable. Okay, types of variable. Yeah, there is not only an integer in types of variable, there are actually more. If I go back here, you will see that I wanted to show some stuff here to display some of the variables that we can have. There are a lot of different variables, but one of them is byte in Java, short, integer, long, character, float, and double. What are these variables? Wow. Each variable has a type, and you can define your variable with a certain type. It depends on how you want to use it. If you can imagine, I want to run this first, and I can show you, which I did here. But when I run it, let's pay attention to this part here. When I run this program, I wanted to show you the size of each variable type. What do you expect? So you have 1 byte for a byte. You have 2 bytes for a short. Integer, you have 4 bytes. Long has 8. Character has 2. Float has 4, and double has 8. What does that mean? It means memory and our hardware, we have location, and each location in the memory, it depends on your hardware architecture and stuff like that. But for storage and memory, we can allocate multiple locations in memory. Depends on the type of variable that we want to use. And obviously, depends on how we want to use it. So you want to put a small box, or you want to put a big box. If you want to put a small box, it's a waste of space if you allocate a huge space in the memory for that. If you want to store a big box, you're not going to be able to fit it if you allocate a small location in the memory. So byte has 1 byte in the memory. Short has 2 bytes. Okay, a long, for example, and double, because these are big sizes, they have 8 bytes in the memory. They can allocate up to 8 bytes in the memory. This is good. You come now when you say, what does that mean? What does it mean to me? How can I actually know which memory type I need to use? What is the code here, or what is the secret about that? We need to understand the next step. Okay, so we need to know what types of variables are and how to use them. Go in this direction, I wanted to use this chart here, and be able to talk about it. We have Boolean that I didn't talk about before, which is basically it's a true or false variable that can store either 0 or 1. Okay, we're gonna see a lot of use of that for testing and keeping track of flags or conditions or stuff like that. Now, byte, like we said, it's only 1 byte. It can have 1 byte in the memory. And that byte in the memory can have a numerical value that go from negative 128 to 127. Okay, so if you want to store and you're working on temperature application and you want to store some temperature into a variable and you create a variable, you can probably create it as a byte, maybe. And I will talk about this as we go. Why? Because your temperature maybe doesn't go higher than 127 and maybe it doesn't go below 128, maybe. But if your temperature and you're working with a different range of temperature and your byte doesn't work, then let's stop here and say, okay, short can store variables with numerical values that can be from negative 32,768 to 32,768. Wow, 767. Wow, so this is really a good variable type that we can work with a lot of programs that can have numerical values in that range. What if we have a bigger number? Okay, look, we can go to int and we create a new variables of type int. And this int, as we said before, is 4 bytes. And the 4 bytes can be this huge number. Okay, how about the long? Wow. Float, okay, and double. This is a little different. You notice that all these variables do not have a decimal number. They cannot be storing decimals, and we'll see that in an example. Float and double are the correct variable types that will help you store variables with decimal digits. So this can have up to 7, this can have up to 16. Let's go back to character. I skipped this one for a reason. Character can have variable with that is a character representation of ASCII values. These values can be of values from 0 to 256. How this works, I'm gonna have to show you what is an ASCII table that describe these characters. We'll go back to it in a minute. So if I go here and look at my list of items, we know now about the types of variable and like roughly what they can store inside these variables. They can occupy a certain number of bytes in the memory. Now, let's look at how the operation goes. How can we use them? What can we do with these variables? That means we have to go back to programming. So I can go here and let me erase all that here for now. And let's talk about something. Before I have int, the variable type, and I created a label value 1, correct? And I assigned a value to it, okay? Something very important, because before we go any further, that your variable name or label has to be unique, and you have to have a good naming convention. What does that mean is, if you have 500 variables in your program, and you come back later and you say, where is my temperature stored in? If I have value 1, value 2, value 3, value 4, value 5, value 10, you end up have no clue where you stored your temperature. But if you say, and my, or let's make a good naming for a room, let's make it even better, bed, room, temperature value equals 23. Okay, this is much better. Okay, what if we have multiple bedrooms in your house and you're trying to create a program to capture all these values? That's not a good one, right? It means we're going to have a better one. Let's make it master bedroom. Master bedroom temperature value equals to 35, okay, 53, whatever number. That's a good way. So now we can have another one, kids bedroom temperature value, and I'm using something here, equals to, let's say, 54. So anytime in a week or a month you come back and redo some work on this code, you will immediately be able to distinguish your variable, the master bedroom, from your kid's bedroom, and you know exactly what you're working, what variable you are working with. What if we have other stuff like temperature? Okay, how about humidity? So what if I create the same thing and put them back here, and what I'm going to do, instead of temperature, let's call it humidity. Okay, humidity. And now you can actually look for the master bedroom if that's where you want to work with, and you either have a temperature or you have a humidity. Let's make these, let's make them 23, 24, so are different. Very important part of variables that you can, as we talked about, create a good variable label with that variable type, and it has to be unique, and make sure you have a good naming convention. Okay, so what if we wanted to do a printout for that? Would this work now? Obviously we have to do some work here to get them to work. So I'm gonna print line, and I'm gonna pass something to them. I'm gonna say, okay, bedroom. Let's get rid of that. We don't need the bedroom anymore because we had a better variable naming for the master bedroom temperature value. Let's say that, and then we'll go and add to that string the value of my master, and you can tab space, and this will give you hints for the existing variable that you created, so you don't have to type that again. I want to have the master, not the humidity, the temperature, and now we're done. I can take this here and basically replicate it or duplicate it and have more of them. Okay, so instead of the master bedroom, I'm gonna say kids bedroom, and I'm gonna change this to kids, and then I'm gonna say master bedroom, instead of temperature, I'm gonna say humidity, and the same thing here. But I have to be careful, I have to change this here to kids, and make sure this is kids. And instead of temperature, I am interested in this part to print humidity. And I come back here and also change this to humidity. And as you can see, this red line, underscore, underscore, red line, it's kids, bedroom, humidity value. What did I do wrong? Let's actually get rid of all that, and let's look for the hint. And I want to do this one. Humidity, humidity, and temperature. What did I do here? Let's get rid of that. That's something. Thomas typed something, and I need the kids' bedroom temperature. Oh, value. See what I did wrong here? This is bad, right? So see, that's part of value. And I did the same thing here. Of course, this here now is not going to like it, so let's go back and update it. That's what I like about this immediate debugging and error check in the programming, because it will show you a red line if something doesn't make sense. I also do a lot of copying, so we have to be careful when you copy and program. And sometimes with a small program like this, there's not a big deal, you're gonna find it. However, with program that has hundreds and hundreds of instructions, lines, you will have a problem understanding or figuring out where the problem is. We'll work on that later anyway. So now I'm gonna save, and you can see here that I have this old variable with value 1. It has a green underlined, which is only saying that I created that variable, but I never used it. So we either can keep it. It's not a problematic at this point, but it's a waste of memory because we allocated a space in the memory that we never use. So what I'm going to do is I can delete it and get rid of it for now. Okay, I'm going to save and run it again. This way I can make use of this work here. I should be able to see master bedroom temperature as I'm expecting. Temperature and humidity, kids bedroom, master bedroom, and kids bedroom humidities. Okay, so mission accomplished. We created variables. We have a good naming convention. We know what type we choose, and that type based on kind of the size or the max number that we will be using for temperature. That works fine. And then we did print to it, which means we read that variable. We went to the memory, found the location, and we read what was stored in that location, and now we print it out there to the user. I hope that helps and clarify what variables are, and I hope I was able to, let's see, where was my presentation? Here it is. So I hope I went through all these, explained it. I hope if you have any question, you can comment down below and give me some information or question or suggestions of what to add or anything else that you need to explain. I'll do my best to do that. And thank you so much, and hope this video again was useful, and be safe out there.